Okay. All right, so section 9.1 is right triangle trigonometry, like I said. And so we have to define some terms here to get started. And you've seen these before. I'm going to draw a little right triangle over here to help us kind of get through these. And in this right triangle, I'm going to introduce to you a new variable. I think it's new. You can stop me if you've seen it before. But usually we use x when we're dealing with things that we don't know. Whenever we're talking about angles that we don't know, the most typically used one is actually this guy.
I think I know what you're talking about.
You seen that before?
Yep.
Anybody know what that's called?
Oh, I used to.
It is a Greek letter, yeah.
It's called, it means a degree.
No, it doesn't actually. Its name is theta.
Oh.
It's the Greek letter theta, and it is the variable that we use most often with angles. So anytime that we're talking about an angle in here, I'm going to use theta instead of x. Okay. Now your textbook might switch back and forth a little bit just because technically does it matter what variable we use as long as we know what we're talking about? Not really, but just to kind of keep things clear most of the time, if we're talking about a missing side somewhere, I'll probably use an x. If I'm talking about a missing angle somewhere, I'll probably use a theta. All right, just so you guys are aware there. Okay, and then in relationship to theta, we can give names to the three sides of the triangle. So anybody remember what is the side of the triangle? Don't answer before I'm done asking it. What is the name of this side? It's always the longest side of the triangle. It's always across from the right angle. Thank you for raising your hand. It's the hypotenuse. Yeah, that's called the hypotenuse, and it is spelled Hypotenuse. Okay, and what do we call the side that is not the but is the other side that is right next to the angle we're looking at? Adjacent. Yep. That's an A. Oh, you mean the variable here? It's called theta. It basically looks like an egg with a line through it, if you want to draw it that way. Okay, and then the other side of the triangle, okay, it is opposite of the angle, so it's called the opposite side. Not really, but okay. Opposite side. All right, so we have adjacent, opposite, and hypotenuse, and usually we just denote those with an H, an A, and an O when we're using them. So our three trig functions that we have studied in the past are called cosine, sine, and tangent. And it is the cosine of theta, the sine of theta, and the tangent of theta. And each one of those is equal to a fraction or a ratio. Usually these get called the trigonometric ratios. So they're the ratios that get used in trigonometry. So cosine of the angle is the adjacent side divided by the hypotenuse. And the sine is the opposite side divided by the hypotenuse. Anybody remember what the tangent is? Opposite over adjacent, yes. Mm-hmm. Okay. And probably, not all teachers do this, but probably you learned something, a way to remember these that sounds like something Native American. SOHCAHTOA is just a quick way to remember which one goes with what, okay? I probably should have done sine as the first one up there to keep it in the same order. But sine S is the over OH. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Okay? So it's like kind of a quick reference to tell you what's what. Okay? So let's practice real quick. I'm going to draw a little right triangle. I'm going to label some of the sides with some measurements. And I want to see if you guys can tell me what the cosine, sine, and tangent are. And I'm going to show you some abbreviations that you can use for each one of those too. Okay, so let's say we got this right triangle to work with. This side is 3, this side is 4, and this side is 5. Now you can check me on that. It's a right triangle, so those 3 sides should all work in the Pythagorean theorem too. All right, so 3 squared plus 4 squared equals 5 squared. You can check it out. It works. Okay, it's a 3, 4, 5 triangle. It's a special one. Anywho, let's say that our theta is up here. Okay? And I want you to tell me the fraction for each of these. So instead of writing out the word cosine every time, we can just do cos. Instead of writing out sine, just sin. And instead of tangent, just tan. Okay, but for each one of those, write down the fraction that it should be equal to from the triangle there. We'll call on some random friends here to answer for us. All right, everybody got something for all 3 of those? No. Not yet? Yes? All right, I'll give you just a few seconds to finish her up here.
So we can just do it. You just give us this really hard problem, and then make it easier.
No. All right. Here we go. So, cosine. Alex. 3/5. Good. So it is the adjacent side, which in this case is the 3, over the hypotenuse, which is the 5. 3 over 5. Good. Sine. Reed.
4 over
5. Good. And the tangent. Hannah. Kelsey. 4 over 3. Good. Opposite over adjacent. Okay. So, all right. Now, the other trig functions that you guys probably haven't seen before. Nope, not those. So we're going to quickly talk about these two because you'll need these later. So we got secant, cosecant, and cotangent. So in geometry, you learned about 3 of them. There are technically 6. There's 3 more. You do. That's why I'm talking about them right now. So secant, this one is 1 divided by the cosine. Okay, so that's equal to 1 over the cosine. The cosecant is equal to 1 over the sine. And the cotangent is 1 over the tangent. So if you know the cosine, sine, and tangent, you can find the secant, cosecant, and cotangent then. Okay? Zach, you got some notes going over there, big guy? I mean, you do? No. Take it out. Piece of paper. Write it down. Okay. So if Think about what we would need to do then, okay? 1 over something, that's another way of describing it as a reciprocal, which means flip the fraction. So, to the same example here. Here are the abbreviations for the secant, cosecant, and cotangent. It is sec, cosec, and cot. I guess if you want to say them, I don't ever say them, I just write them. But anyway, so if the cosecant is 3/5, what's the secant then? 5/3, right? It's the reciprocal. You just flip the fraction. What's the cosecant and cotangent then? 5/4. And what? 3/4. Okay, so looking at that is then, since the cosine is adjacent over hypotenuse, the secant is the hypotenuse over the adjacent. And because sine is opposite over hypotenuse, the cosecant is hypotenuse opposite, and then cotangent, because the tangent is opposite over adjacent, the cotangent is adjacent over opposite. You don't have to do that, though. I think it's easier to think of them this way, like which ones relate to which ones, and then if I know these three, like we just did right here, just flip the fraction of those three and you got them all. Okay? Question, Brock? The theta that next to it? Yes. That's one of my pet peeves, actually. Yeah, a lot of people don't write the little theta next to them, and if you don't have a little theta next to it, it doesn't mean anything. So it's the, yes. So it is the cosine of theta. It is not just cosine. It's always of the angle. So you have to make sure the angle's there, because it's very important, because if I had an angle, let's say down here, the cosine angle down here is very different from the cosine of the angle up here, right? Yeah. It's not the same thing. So if you don't tell me what angle it is, I don't know what you're talking about. So you have to tell me what angle it is. Because sometimes we'll have triangles where you're looking at more than one angle, and we got to know which one is it. So then it would be cosine A and cosine B or whatever. Yeah. So my lecture for just a second. And I want you guys to turn to page 242 in your journals for me. We're going to take a look at a little investigation here. Wait, there it is. Okay. So let's say we've got a 30, 60, 90 triangle here. And I know that this side of the triangle is maybe 12 inches. And I want to figure out what are the other two sides, x and y. So keep in mind, well, I'll just, instead of writing it all out, I'll just write SOHCAHTOA up here. All right, and what we're going to need to do is to set up a trig equation that uses the side that we know, the 12 inches, somehow. Okay? And I can use the 30-degree angle. I can use the 60-degree angle if I want. Doesn't matter. But somehow I'm going to have to use that 12. Okay? So I'm going to do this first step for you just to kind of show you what I'm talking about. And then in the future, we'll see if you guys can come up with it for me. But I'm going to do the cosine of 30. Now, without looking back at the journal stuff that we did, but just looking in this triangle and thinking SOHCAHTOA, what is the cosine of 30 equal to? It's what over y? 12 over y. Cosine is adjacent over hypotenuse, right? The adjacent side to 30 degrees is 12. Hypotenuse is y. So cosine 30 is 12 over y, okay? But somebody who still has their journal open, what did we just find was the cosine of 30? Square root of 3 over 2, right? So this equation then is going to become the square root of 3 over 2 equals 12 over y. Does that make sense, though, what we just did? We essentially did a substitution, right? We said we already know the cosine of 30. The cosine of 30 for all time, no matter what triangle you're looking at that has a 30-degree angle in it, is square root of 3 over 2. So anytime you see cosine 30, you can replace it with that. And this particular triangle, it was also equal to 12 over y. So those two things are equal to each other. And now we can go from there to solve it for y. Yeah? The lengths can vary, but the angle, the cosine, sine, and tangent do not. Those stay the same, no matter what. So now that I have that plugged in for cosine 30, what can I do to solve this that we've done before? Do a proportion. Do a little cross multiplying. 2 times 12, 24. Y times the square root of 3. Well, square root of 3y. So that missing side, y, is 24 over the square root of 3. So I found y. Okay. Can somebody else give me a different method that we could use? Not a different method, but a different equation that we could then use to find x. If we do kind of the same thing we just did. We could do a TOA. Okay. TOA of 30 or 60? Which one do you want? Oh. I heard more 60s than... Okay. It doesn't matter. It works either way. But okay, so let's say we're doing tangent of 60. Now, in this triangle, tangent of 60 should be what? (12 over x). Over adjacent, right? Is the tangent. Okay. Look back in your journal if you don't have it open. What did we already say was the tangent of 60? It's just the square root of 3, correct? So this equation then becomes the square root of 3 equals 12 over x then. If you would rather, if it makes more sense to you, and you want to make this square root 3 over 1 so you can do your cross multiplying a little easier, that's fine. Be 12 times 1 equals square root of 3 times x. So the length of x would be 12 divided by the square root of 3. Okay, so if you know those sine, cosine, tangents that we talked about, you can do this. And it doesn't matter, like if you, there's certain ones that won't work, but as long as it involves the side that you know, you can use sine, cosine, or tangent, and it doesn't matter. Like with this one right here, we could have done, what, the tangent of 30 as well, right? Tangent of 30 would give you over adjacent, and then we could have worked it that way, and we would have gotten to the same thing when we were done. This one right here, cosine of 30 equals 12 over y. Instead of doing the cosine of 30, I could have done the sine of 60, right? Sine, opposite over adjacent. That should have worked too, okay? So there's always more than one option for you with these, and you'll get the same answer when you're done, okay? These only work right now if we have a 30, 60, 90 triangle or a 45, 45, 90 triangle, because those are the ones we know the sine, the cosine, and the tangent, what the numbers are, what the fractions are for each of those. Your calculator can tell you the sine, cosine, and tangent of any angle you want. It doesn't have to be 30, 60, or 45. Okay? So we're going to do a little calculator work here now and take a look at another triangle and see if we can find sides on this one. Doing the same time calculator to help us along here. All right. So I want to find x and y in this triangle. Oh, no, it's a y. So can somebody give me a trig formula that I could use that would work? Do I want to do a tangent? Okay. So we'll go tangent. Now, the only angle I have to work with is 52 right now, so it's got to be tangent of 52. You could find this one, though, if you wanted to, right? You could do 48. Yeah. Or it'd be, what? No, 38, right? It'd have to be 38. Anywho, for right now, we'll go tangent 52. So if I'm going with the 52, it's going to be equal to what over what in this triangle? Adjacent, x over 10. Okay. Now, at this stage, we'd go, okay, what's the tangent of 52? Let me flip back, find the tangent of 52. Oh, wait, it's 52. I don't know that. But your calculator does. So okay, so if you look, you've heard this before, sine, cosine, and tangent are right there. So if what is this? The tangent of 52. It's going to look like that. Now, one thing you got to be careful of, if you hit enter here, you might get one of two different answers. So it might be negative 6.05 or it might be 1.27. Okay, this is wrong. If you got the negative 6, it's wrong. Now here's why. The mode of your calculator needs to be in degrees. There are two different ways to measure angles, which we'll talk about quite a bit actually. There's degrees and there are radians. And so right now my calculator, if you look at the third option here, my calculator's set in radians. It needs to be in degrees. I got to switch that. As soon as you switch that, just go second and then hit quit. And then if you hit enter one more time to try it again, there's the right answer, 1.27. Or 1.28, I guess we rounded it. So, and since we're dealing with 52 degrees, this is 1.8 rounded. So now that equals x over 10. And so now we got to solve for x the rest of the way, which is pretty simple. What do I got to do? Times 10. Yeah. So 1.28 times 12.8. Yep. There's your x. You can applaud. No, it's fine. All right. Can somebody give me another equation for finding y? Want to do the cosine? Okay. So the cosine of 52 equals what? 10 over y. Okay. So take out your calculator again. What's the cosine of 52? Yeah, so about 0.616. Thumb here, guys, with these. If you take it out at least 3 decimal places whenever you're doing trig, it's pretty safe. Okay. So 0.616 is what I'm going to go with here for this one. Okay, now it's 10 over y, so what now? Times it by y and then divide by 0.616. You guys remember my little trick, though? You can just switch them. So 10 divided by 0.616 should give you the same thing. So what is that? Sure. Y equals 10 over cosine 52? Sure. Mm-hmm. Yeah, it would. That's the way to look at it, so that's pretty sweet if you want to do that. He said you could take the cosine 52 and the y and switch them right there. So y is equal to 10 over cosine 52. Yeah, for sure. Y ends up being about 18.2. So we found our other two sides of this triangle. And kind of check, just to make sure you didn't screw something up somewhere along the line here. It's supposed to be the biggest number, right? So look at your y. Is it the largest number of all three sides? Yeah, 16 is bigger than 12 and it's bigger than 10. So, yep, we did good there. Do what? The right angle. Mm-hmm. Yep. So, okay. We really need to make sure that we get to here. What if, and I'm not saying angles. You don't guess. Come on, this is math class. When do we ever guess? Well, sometimes we estimate. We don't need to here. So we got to. Let's say I know this side is 24 inches, and this side over here is maybe like 18 inches. I find theta. And what the heck? Let's find two. Another variable here. Your book doesn't use it, but it looks like a flattened little circle with a line through it, and that's called rho, R-H-O. So you have theta and rho. It's our two angles here. So you keep them straight, which is which. That's the important thing. So remember, it's the cosine, the sine, or the tangent of the angle. Okay? So can somebody give me an equation that involves theta somehow? Yeah. Yep. Tangent's opposite over adjacent. So tangent of theta is 18 over 24. Does anybody remember from geometry how we go about finding theta? Yeah? Yeah. It's called the inverse tangent. If you look at your calculator really closely, above tangent, it's kind of hard to find because it's all black, but there should be a sine with a little -1, a cosine with a little -1, and a tangent with a little -1. Those are called the inverse sine, inverse cosine, and inverse tangent. And basically those are what angle gives you a, like for inverse tangent, it would be what angle gives you the tangent of 18 over 24. So these actually, is remember to convert that, are pretty easy. This becomes the inverse tangent of 18 over 24. And so then you can just type that on your calculator and get an answer. Okay, so second tangent gives me the inverse tangent, 18 divided by 24. And I get about 36.9 degrees. Theta is 36.9 degrees. Oh, it's not very difficult. What could you do? Yeah, you know 2 out of the 3 angles in a triangle, and all 3 angles in a triangle always add up to what? 180. So couldn't you just do a little subtraction work on that thing and be done? Yep, you could do that. Or, nothing wrong with it, you could do what? Do another inverse tangent for rho, and that's fine. It would work. Okay? You don't have to copy if you don't want to, but I'm going to do that. What is the tangent of rho? Yeah, it'd be 24 now, adjacent to 18, so 24 over 18. And then the rho is inverse tangent of that. So I'll try that on my calculator. So those of you that are doing subtraction, you can double check me here. But I got rho is equal to 53.1. Should be 53.1 plus 6.9 plus 90 should be 180, correct? It does work, yeah. Okay, cool, cool. Thing I want you to do. Got it. Okay. So let's say that we know that the sine of some angle, I don't know what the angle is, but let's say the sine over 19. And so what I would like to find is if I over 19, what's the cosine of theta? What's the sine of theta? Oops, I already know the sine. Never mind. Tangent. That'd be the easy one. Okay, so what's the cosine? What's the tangent? What's the secant? What's the yeah. What's the cosecant? What's the cotangent? Not as bad as you might think, okay? Be even without using a calculator too. Like, we can do this by hand just fine. If you draw yourself a triangle, you can pull this off without much trouble. So just some kind of right triangle. And theta has to be somewhere, so let's say theta is like down over here. Okay? If the sine of theta is 3 over 19, where on the triangle should be the 3 and where on the triangle should be the 19? Okay. I heard people say that more or less. The opposite side would be 3. Hypotenuse would have to be the 19 then, right? Opposite over hypotenuse, that's sine. If sides of a right triangle, I can always find the third using what? Pythagorean theorem, right? Still applies, right? Now, C is always the hypotenuse. So with 3 squared plus b squared equals 19 squared. And so I got 9 plus b squared equals 361. Okay, good job. 361. So b squared is 361 minus 9, which is 352. So b, and yes, it is okay to leave it this way, is the square root of 352. So, it's exactly 18? Yeah, we're going to just leave it as a square root, because to do it without a calculator, you wouldn't be able to figure that out. So, okay, so, sides, can't I all of these now? Yeah. So, cosine. Adjacent over hypotenuse. Right. Adjacent is square root of 352. Hypotenuse is 19. Tangent. Tangent is opposite over adjacent, so there you go. Secant. That is the reciprocal of what? Cosine. It is the reciprocal of cosine. I know, the letters don't match. I get it. It's confusing. I know, but it's the truth. So secant is the reciprocal of cosine. Just remember that the letters flip-flop. So this would be 19 over the square root of 352. Now, is the reciprocal of what then? That's the reciprocal of sine. So what's the cosecant? 19 over 3. And then what's the cotangent? Square root of 352 over 3. It's the reciprocal of the tangent. Okay? So, like I said, if you can draw the triangle, if you can get all 3 sides on there using the Pythagorean theorem, then you can just look at the picture and get all of these. Okay? So they're going to ask, like, if the sine is equal to 3 over 19, of the 5 other trig functions. Well, that's exactly what we just did. Okay? So, thank you. So I'm going to let you guys get to work on this stuff then, now that you have a little entry point here.